Welcome to Unit 2, Lesson 7, Comparing Relationships with Tables. We're going to start off with the warm-up. So the warm-up says a lemonade recipe calls for the juice of 5 lemons, 2 cups of water, and 2 tablespoons of honey. Invent 4 new versions of this lemonade recipe. So answer the 4 questions, pause the video, take about 5 minutes, and then come back. All right, welcome back. So we're going to start with the first one. So it says one that would be make more lemonade, but taste the same as the original recipe. So one that would taste the same, make more lemonade, but taste the same. So what we could do, and this is just an example, yours could be different, is we could double each of this. So we could have, say, 5 times 2, that's 10 lemons. 2 times 2 is 4, so 4 cups of water. And 2 times 2 would be 4 tablespoons of honey. All right. One that would make less lemonade but taste the same as the original. So we could kind of cut these in half. So instead of multiplying by 2, divide by 2. So half of 5 would be 2.5. So 2.5 lemons. Half of 2 would be 1 cup of water. And half of 2 again would be 1 tablespoon of honey. All right, number 3, one that would have a stronger lemon taste than the original recipe. So we could take the original recipe and add a couple of lemons. So even if we added 1 more lemon, it would be a little stronger than the original. Let's say I want 8 lemons, and I want to keep the same amount of water. So 2 cups of water and 2 tablespoons of honey. So that would keep it the same, except for there would be more lemons and it would be stronger. One that would have a weaker lemon taste than the original. So our original has 5 lemons. We want to use less lemons. So let's say maybe this time I'll use 2 lemons, 2 cups of water, and 2 tablespoons of honey. And that would give it a weaker lemon taste than the original recipe. And let's turn the page from 121 to 122. I'm going to look at the top of the page. It says entrance to a state park costs $6 per vehicle plus $2 per person in the vehicle. How much would it cost for a car with 2 people to enter the park? So let's start with just that first one, 2 people in the park. So we have 1 vehicle. We know our base cost for vehicle is $6, and then it's $2 per person. So if there's 2 people in the car, we would have to multiply 2 times 2, which would give us 4. So 6 plus 4 would give us $10. Pause the video and try to see if you can find 4 and 10 people. All right, welcome back. Let's see if we got the right answers. So we have 1 vehicle, but it's got 4 people in it. So we keep our base cost of 6, and we have $2 per person. So it would be 2 times 4, which would be 8. So if we have 6 plus 8, we're going to have $14. So this one here was 6 plus 2 plus 2. 6 plus 2 plus 2 plus 2 plus 2. And now we have 10 people. So we can even say this is equal to 6 plus 2 times 2. This would be 6 plus 2 times 4. So that way we don't have to write it out so much. So in this case, we know it's going to be 2 times 10. We have one vehicle, so 6 plus 2 times 10. 2 times 10 gives us 20. So the cost of this vehicle would be $26 for 10 people in one vehicle. And that's a lot of people in one little car, huh? All right, number 2, for each row on the table, if each person in the vehicle splits the cost equally, how much will each person pay? So let's figure that out. So our first vehicle is $10, so we would have to do 10 divided by 2. So 10 divided by 2, how much is everybody going to pay? Yeah, that's right, they're going to pay $5. All right, let's look at the second one. We have 4 and 14. So 14 divided by 4. I wonder what that is. I'm going to grab a sticky note and we can do the division on the side. So 14, 4. 4 goes into 14 3 times. We end up with 12. Subtract 2 left over. 4 goes into 20 5 times. And if we're making this money, we need that extra 0. So they would pay $3.50. Right, 10 people, and we have 26. So we're going to do 26 divided by 10. 26, 10, goes in twice. 20, we end up with 6. 10 goes into 6 times. So we would end up with $2.60. So the more people in the vehicle, it looks like would cost less per person. How might we determine the entrance cost for a bus with 50 people? What do you think? So first off, we got to remember it still costs $6 for that vehicle to be there. So we would have our $6, and then how many people are on the bus? That's right, 50. And how much does it cost per person? $2. So $2 times 50 people, 2 times 50, we're going to end up with 6 plus 100, and a result of $106. Right, number 4, is the relationship between the number of people and the total entrance cost a proportional relationship, and how do you know? Take a moment and answer this question. All right, so we can say no, because if we're looking here, the cost per person goes down with the more people in the vehicle. So it's going to cost 2 people $5, but 4 people $3.50, and 10 people $2.60. So that's not a proportional relationship because this is going down. So let's say, considering the ratio, now if you remember, our ratio in this case would be 2 to 10, 4 to 16, 10 to 26. Of people to cost, these are not equivalent ratios. Let's turn over now to page 123. So activity 7.3, running laps. Han and Claire were running laps around the track. The coach recorded their times at the ends of laps 2, 4, 6, and 8. So here we see Han's run. So for him to run 2 laps, it took him 4 minutes. For him to run 4 laps, it took him 9 minutes. To run 6 laps, 15 minutes. 8 laps, 23 minutes. For Claire, 2 laps took 5 minutes, 4 laps took 10 minutes, 6 laps took 15 minutes, and 8 laps took 20 minutes. So first question is asking, is Han running at a constant pace, and is Claire? How do we know? Well, in order to answer that, we've got to figure out how many minutes are they doing per a single lap. So let's figure that out. Let's look. Now, you might want to grab some scrap paper, but in this case, Miss Bailey's going to use her sticky notes. So let's start first off with Han's run. So his first one, he ran 2 laps in 4 minutes. So we've got to figure out, if we divide 4 by 2, how many minutes does it take him to run 1 lap? So 4 divided by 2, that's going to be 2. So it takes him 2 minutes per lap there. To run 4 laps, it takes him 9 minutes. So we've got to do a little bit of division here, and we're going to divide 9 by 4. So 9 by 4, 4 goes into 9 twice, gives us 8, subtract, we're left with 1, got to bring down a 0 now. 4 goes into 10, still 2 times. We subtract, we're left with 2, bring down a 0. 4 goes into 25 times. So it takes him 2¼ minutes to run a lap for the second one. 2.25. Right, pause the video and see if you can find for 6 laps and for 8 laps. All right, welcome back. Let's check your answers. So the next one, we're going to do 15 divided by 6. So 15 and 6. 6 goes into 15 twice. That's going to give us 12. 3 left over. 6 goes into 30 5 times. So this one is 2½ minutes per lap. And our last one, so we have 23 divided by 8. 8 goes into 23 2 times. We end up with 16. 13 minus 6 is 7. I'm going to have to add a 0. 8 goes into 70 8 times. We're going to end up with 64. Subtract, we're going to have 6 left over. Bring down a 0. It's going to go in 7 times. 8 times 7 is going to be 56. We're left with 4. I'm going to bring down another 0. 8 goes into 45 times. So we have 2.875. So it takes him 2 minutes, 875 thousandths of a second to get there. Okay, let's look at Claire's run. So I'm going to grab another sticky note. for Claire. So Claire's run, we have 2 into 5, so we're going to do 5 divided by 2. 2 goes in twice, we end up with 4, 1. 2 goes into 10 5 times. So we have 2.5. And do the same thing, fill in the rest of this table and come back to check your answers. All right, welcome back. So let's check your answers. We have 10, 4, 4 goes into 10 2 times. We end up with 8, subtract. We have 2 left over. 4 goes into 20 5 times. So this one is also 2.5. Let's see. This one is 15 and 6. Goes in twice. We end up with 12. 3 left over. Bring down that. 5 times. 2.5. I'm noticing a bit of a pattern here with Claire's. All right, 20, 8, 2, 16, 4. Goes in 5 times, 2.5. So all of Claire's are 2.5 minutes per lap. So she's very consistent. But Hans is not so consistent. It increases with each lap. It takes him a little bit longer to do that lap. So we can tell that Hans is not running at a constant pace, but Claire is. We can say Hans isn't running at a constant pace because each additional lap takes him longer. Claire, though, is running at a constant pace. And we know that because it stays the same for each interval of laps. All right, so Hans isn't running at a constant pace because each additional lap takes longer. Claire is running at a constant pace because each lap takes her 2.5 minutes. All right, number 2 says write an equation for the relationship between distance and time for anyone who is running at a constant pace. So we're looking at distance and time. So in Claire's situation, we know she's running at a constant pace. So we're just going to look at Claire's. So we've got to figure out what equation could this represent. So if we do our distance, let's represent that with a D. And our time, let's represent that by a T. So now we've got to figure out what is Claire's constant pace. Well, we already solved for that. It's 2.5. So her distance is going to depend on how long she's running. So if each lap takes her 2.5 minutes, we're going to put 2.5 times time, because this is going to depend on what this is going to be. So this relies on the minutes per lap. So she is always running 2.5 minutes per lap. So if she were, say, running 5, it would be a number in between, and it would be 12.5. All right. That is the end of lesson 7. Please complete 125 and 126 for homework. All 4 questions. I will see you next time for our next lesson.